numbers to get us started. So factoring out 40, factoring out 33. Ultimately, we're going to end up at greatest common factor, but we're not going to dive into that right off the bat. So we start off with 40. Now here is how I would like you guys to do this. I tend to use what's called a tree diagram. And yeah, this is 8-1, factoring and greatest common factors. And I prefer to do a tree diagram when I factor. There are other ways you can do it involving like a stair steps down. If that gets you to the final factorization, I can live with it. So we start off with 40. What are two numbers that divide evenly into 40? 8 and 5. 20 and 2. 10 and 4. Here's the one nice thing about factoring is that you really can't do it wrong in the sense of which one you pick. As long as you just keep going until you get down to all prime numbers, you're fine. Before we get too far off, though, what is a prime number?
Number that cannot be divided.
It's not divided in half. Not quite.
You know what I mean by it.
No, I don't. Right. The only factors in a prime number, are 1 and itself. So examples of this are the numbers 5, 11, 13, 17, 23. Those are all prime numbers. Nothing divides evenly into them except 1 and that number itself. So when we talk about the prime factorization of a number, our goal with this tree as we work our way down is to find all of the prime numbers that go into it. So for example, with 5, we're stopped. We can't go any further than 5. 8 we can. 8, that's 4 and 2. And 4 would be 2 and 2. And 2 is a prime number, so I stop there. I've seen students keep this going where they're like everything is a number times 1. You don't have to do that. Once you get down to a prime number, you get to stop, because if you keep doing times 1, you'll be there for an infinite period of time, because 2 is 2 times 1, 2 is 2 times 1, 2 is 2 times 1, 2, and see all these 2's and 2's, and you just keep going down the page. Don't do that. I had someone do that one of my first years teaching. She went all the way down and flipped over and kept going with 3 times 1. Because she kept factoring 3 as 3 times 1. Yeah, don't do that. No, don't do that either. 1 is a prime number, stop. Well, that's up for debate. Go ahead and... Actually, my pencil sharpener is broken, so you'll be there a while. Why don't you borrow one of my mechanicals? Yeah, that one works. Yeah, well, let's not sweat it. Now, we're not actually technically done with our problem yet. We need to write out the... yeah, that one's perfect. We need to write it out like that. So we take all of our numbers, group them up, and the last step in the prime factorization is to write it with an exponent. Be prepared to give either answer. I'll take either answer. I'm open that way. But that's kind of where you need to get to. Any questions on where the 2 to the third came from? Yeah, 2 times itself 3 times, times another 5 will give me a 40. 33 is not too bad, because 33 is just 3 times 11, and we're done. Right off the bat, our first 2 obvious factors are both prime numbers, so we can't go any further with it. Thank you. What can I say about this so far? We're just starting off. It should be.